Hi everyone, in today's video I'm going to speak about expanding brackets. So we're going to expand brackets for the whole video. What I mean by that, and I think I should put it just under here. So this is, we're going to multiply brackets. That's kind of what we're gonna do. So we are going to start with single brackets. So we're gonna start with single brackets. And before I go on and do anything related to that, just to let you know, this is one of my favorite subjects, or part of a subject, because algebra is my favorite part of maths. So yeah, no issues there, but I'm very excited. So first example, we've got 3 multiplied by x plus 4. So we have most of the time, actually I should say all of the time, we basically do not write the multiplication sign between the number and the bracket. So I'm gonna write it now just for you to know what is happening, but we rarely write this, or basically never. We omit this multiplication over there. Now, when we do this type of question, what you have to understand by this or this is that I actually have 3 of these brackets added together. So what I have, and I hope I have enough space, I'm going to change this one and write like this. So what I have actually 3 of these brackets added together. So I've got an x plus 4 plus another x plus 4 plus another x plus 4. So I've got 3 of them together. And in this situation, it's easy to see that I actually have 1, 2, 3 x's. And I have 1, 2, 3 4's. I'm adding them together, so my final answer should be 3x plus 12. And that's exactly what I'm doing here. Is I'm not gonna write this all over again. So the way I do this and how I make sure I don't make any mistakes is I take the 3 and I multiply it by the first thing in the bracket, and then I take the same 3 and I multiply it by the second thing in the bracket. So I do 3 times x and I do 3 times 4. So that's 3x plus 12. Pretty straightforward, lovely example, lovely topic. Second example, I'm going to go with a negative number in front. So I've got negative 2 times, let's go with x minus 2. So I'm gonna go straight on to the method, but I want to make sure I don't make any mistakes, because I'm multiplying all of the negative 2 by the first thing and all of the negative 2 by the second thing in the bracket. So I need to be very careful because of the sign there. So I'm actually gonna write the negative 2 into a little bracket, x, and then I am going to do the same negative 2 times the 2 with the sign in there. So what I should have mentioned on the top is, like, you see this plus, this is the plus that moved there into this plus there. So what I'm doing here is, like, this minus is the minus there. So I have to be very careful because I'm multiplying by a negative number. This becomes negative 2x, and this is a minus and a minus, which makes a plus 4. So very careful with this one. It does sound like it shouldn't be any issues, But if you don't pay attention to the negative signs, there could be issues and you could have a completely different answer. And I think the issue comes with this, with the second part of the question and not the start of the question. So this is for single brackets. I do think I went a bit fast on this, but there's nothing else to say about it. It's just multiplying things together. And if you understand what's happening, then it's very straightforward and it's pretty relaxing to do, if you ask me personally. But yeah. The next bit I want to go on, and it's the bit that we're going to spend a bit more time on, is 2 brackets or 3 brackets. So that's, let's say, let's call it double brackets. Oh, I just realized there I forgot a C. Ha. Oh, it's gonna bother me so much. I'm just gonna insert it there. That's it, life. I forgot a C. So double brackets. Double brackets means you actually have 2 brackets multiplied by each other. If you understand this, you will understand how to do 3 brackets, 4 brackets, and so on. So this is the important bit. Obviously, this is going to be based on the single bracket we've done on the top. So I'm going to start with, how do I want to play this? Because I have so many examples. Let's call this example let's call this part A. Part A with example 1. You're gonna see what I mean by this later. So this is A with example 1. So the first example is x plus 3 multiplied by x minus 2. So again, as I said before, we don't put the multiplication sign anymore in between them. We're just completely omitting it. Now, to understand what's happening here is basically the same as what I've done on the top. It's just, it looks like instead of having just one number in front of my bracket, I have another bracket, but there's no issue with that. I can still follow the same idea, but I'm going to split this in 2. So I'm actually going to put a line, split this in 2 like that, and you're going to see what I mean by that. So I do x times everything from the second bracket, and then I do 3 times everything from the second bracket, and it just becomes single bracket. So it becomes x times everything from the second one plus 3 times everything from the second one. So it's just the first and the second and the plus. You need to be very careful with the plus. If I have a minus there, I should have a minus there, and it just becomes single brackets. So there's nothing incredible or no magic that happens over here. It just becomes 2 single brackets, which is fine. So I do x times x, which is x squared, and I do x times negative 2, which is negative 2x. So that's my first bracket. Just gonna put it there, my first bracket. And then I do 3 times x, 3x, and then I do 3 times negative 2, negative 6. This is my second bracket. And I didn't do a lot of stuff yet. I didn't complicate my life. Everything was quite straightforward. Now what we need to be careful was I need to tidy up things, which means I have to look around and see which of the things are the same. And I have this negative 2 and this plus 3x over there. So I think I'm gonna put them into little boxes. So I have this, and I've got this. and they are the same term with different numbers in front, so I need to actually put them together. So this gives me x squared plus x minus 6. Done. Completely finished. No issues. Now I'm just gonna make 2 little arrows over here. So first thing first, I think I want to mention these 2 things here. They're just single brackets, and this bit here is the simplifying. So very careful with this, because I always have to simplify at the end. I can't just leave it like that. And yeah, this is kind of it. There's nothing I can say to this. Absolutely no interesting bits. Just want to follow on with another example, because I think these ones, the more you do, the more you get used to them and you understand what is happening. So I'm going to go with 2x minus 3 and x minus 2. So again, the more you do, the more you get used to it, because this is more like a procedure that you have to remember, because the understanding is pretty straightforward from my point of view. So I've split this into 2. And again, I am very careful with the sign there. This is a -3, so I do a -3 there. So 2x times x, that's 2x squared. 2x times -2, that's -4x. -3 times x is -3x. -3 times -2 is +6. So again, have to be very careful. Then I'm looking at this one and this one, because they are the same. So I've got 2x squared minus 4x minus 3x, that's minus 7x, and then the +6 is as it is. So nothing interesting so far. Just gonna go on with a third example. X minus 2 and x minus 2. Now this is a bracket squared, so this is the same as x minus 2 squared, but it goes on and follows the same idea. So I do x squared minus 2x minus 2x plus 4. So at one point, after you get so used with this, you're gonna see that like different parts of this, they kind of go away when you do your solution. They kind of like, the method gets shorter and shorter, because you're just so used with the method and you understand what's happening that you put less steps in it. And again, I'm looking at the middle ones. I've got x squared minus 4x plus 4. Example number 4, I'm gonna go with x plus 3 squared, which is x plus 3, x plus 3, x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. Now, I've specifically done 2 brackets squared at as these 2, because there's a little pattern that's happening over here, and I am excited for it. So this one, it's a little pattern. So it's a little pattern over there, and from this little pattern, mathematicians actually came up with a formula, because believe it or not, we want to spend less time on doing all of this and more time on solving other more complex bits. So we like patterns, we like to find the rule of something, and we came up with a formula. So now I like to be myself as a mathematician, but like the mathematicians came up with the formula. So it has to do with the x and the 2. And it's very interesting. Like we can see, we always have the first thing squared in both of these, the second bit squared at the end in both of these. And then when we multiply, we actually have 2 of the same thing in the middle. It's always 2 of the same thing in the middle. And that's what the formula is. And I think it's a really cool formula, and I quite enjoy it. And it was one of the first things I've actually remembered without putting any effort, any specific effort in it, because I found it so cool. I just remembered it straight away. I didn't have to do a lot of mental calculations or like mental games or anything like that to remember this, because I found it like fascinating. So let's say I have an a. I either have a plus in the bracket or I have a minus in the bracket, a b, and I square this. So every single time I will get the first thing squared, plus if it is a plus in the bracket, or minus if it is a minus in the bracket, 2 times a and b. Always multiply those 2 together. And then I always have a plus, never a minus, the second term squared. That's the formula. It's a really cool formula. I found it fascinating when I was learning it, and when I first saw it, it never left my mind because of how fascinated I was by it. And I think it's really cool, and yeah, I've loved it. I've enjoyed it. Now I'm gonna continue on with my lovely examples. So I stopped at example 4, so I'm gonna go with example 5. Still haven't stopped. So I've got x minus 2, x plus 2. So this gives me x squared plus 2x minus 2x minus 4. And again, I'm looking at the middle bit. It's very interesting because this time this is a plus 2 and this is a minus 2, so they kind of cancel each other out. So go x squared, this is a 0, and then minus 4. Example number 6, I've got x minus 3 and x plus 3. So I've got x squared plus 3x minus 3x minus 9. Again, follows the same pattern as on the top. I've got x squared minus 9. So again, chose them on purpose. Another one of those that like fascinated me when I first done it. It's another lovely pattern. I'm gonna put it on the side. I love this one. Again, it fascinated me. Again, no surprise here. So we've got a new formula. And again, after you do these so many times and you actually pay attention to what is happening, there's a rule. It's a pattern. It's always a plus and a minus in the middle of the terms that are exactly the same, and they always disappear. So there's no surprise that people came up with a formula, because you don't need to do all of these steps. It's a pattern. It always works. So it's a minus b or a plus b, and it's always the first one squared, take away the second one squared. Obviously it works if the brackets are the other way around. Now, don't get me wrong, in maths, after you see a pattern, you get the formula, it works every time, but you have to prove it. So you have to actually prove that this works every single time. And the way we prove that it works for any numbers is we actually use letters that represent numbers, and we check that it works for any letter. And I do want to do a little proof of this one, the last one, just because I enjoy it, and I think it's one of the easiest things to prove. Like, these two formulas are one of the easiest things you can prove, and you can have fun of this and come up with your own kind of like formulas without looking at what other people have found. This is something you can find yourself. So I'm gonna do a proof. So I am going to start on the brackets, and I'm just going to multiply the brackets. So I've got a squared ab, ba with a takeaway, and b squared. Now ab and ba in our specific example over here, they're exactly the same thing. It doesn't matter if we multiply them like this in this order or not. There are, in your future endeavors of maths, you're going to see that there are specific places where AB is not the same as BA, but in our case, because A and B are any real numbers, you're going to see that it works every time. So yeah, this is another formula. I've put here just a little sign because I do want to emphasize that we know that any two numbers multiplied together, doesn't matter the order in which we multiply them, but there are places in maths where you're going to see that this actually matters. And anything I want to mention about this? Maybe I should mention this has specific name. Most of the time people refer to this as a difference of two squares, because this is an a squared and a b squared, and they are square numbers, so you will see the term difference of two squares. And the last bit, I know this video is a bit long, but bear with me because I am overly excited. So if you go up to this point and you go to the last bit, thank you so much. But I still want to do double brackets, but I want to show you a bit of a more complex double bracket. So let's say I have x plus 2 multiplied, and I don't have just an easy two terms in the second bracket. I actually have x squared minus 3x minus 4. So I have this, like, second or first bracket can be as long as I want to, as long as I remember the same idea. I multiply everything from the second bracket by each individual things in the first one. So this becomes x multiplied by x squared minus 3x minus 4 plus 2 multiplied by x squared minus 3x minus 4. I think it's pretty straightforward. It makes a lot of sense. And now I need to be careful because there are a bit more calculations. So x times x squared, it's x cubed. X times negative 3x, that's negative 3x squared. X times negative 4, negative 4x. So we've done the first one. Second one, 2 times x squared, 2x squared. 2 times negative 3x, negative 6x. 2 times negative 4, negative 8. So far, so good. I've multiplied. Now, the issue here is the actual simplifying, and I will make an arrow and write simplify because I could actually make a lot of mistakes here if I'm not paying attention, because I have a lot of extra terms than normal. So I've got the x squares and I've got the x's. Then I have just one x cubed and one number by itself, so that's fine. The x cubed is an x cubed. Then I have a negative 3x squared and a plus 2x squared. That gives me negative x squared. Then I got a negative 4x and a negative 3x. That gives me negative 10x. And then I've got the negative 8. Done. Exciting. Yeah, this is everything I wanted to do and to explain here. I'm actually quite excited. I managed to do this little proof of it there. It's very simple, it's pretty straightforward, and this information there is pretty important. And yeah, very excited for this. I can't believe I've made it so long. Like, I know this video is gonna be incredibly long, but I really hope you had fun, because I had a lot of fun speaking about it and explaining all of this. And yes, I know I'm repeating myself, but algebra was one of my favorite things ever at school, and I get very excited when I try to explain and speak about it. So yeah, let me know what was your favorite thing at school. It doesn't have to be maths related, it can be anything else. And yeah, I will speak to you soon. Have a lovely day. Bye.